I would like to invite you. Do you have any questions here in the audience here in Delft? Maybe I can start. I gave already. I couldn't find you, Wim. You described
It's you.
the way the environmental cost indicator is used in the tender award evaluation in the Netherlands. Could you explain a bit more in detail how this method is used and what the effects of geosynthetics can be in the selection procedure?
Okay. Well, give me a little more time than I had in the presentation. In tenders in Holland for government projects, for projects in the provinces or the large cities, the middle-sized and large projects, they are evaluated on two levels. One is price, of course. The other one is on the quality of the design which is proposed. Up till a few years ago, there were 2 or 3 quality criteria. And nowadays, one of those quality criteria is the environmental burden as a result of the project. And that's done in the following way, that for every project, a life cycle analysis is made from really every product which is used up till the demolishing of the project, everything there, including the maintenance and so on and so on. That analysis is made. Then there is a maximum and a minimum level of environmental cost indication, which is set in the tender document. In Dutch we say milieukostenindicator for those who are not so familiar with the English term. And that environmental cost indicator is in fact a method to calculate in a standardized way the cost for a society to involve, which is involved with the emissions which are the result of a project. So it's a normalized way. In Holland we have now, Rijkswaterstaat has made a calculation, a computer calculation called JuboCalc, which you have to use as a contractor and have to hand, the results of that have to hand in with your tender. And then every quality criterion, there are 3 of them, every 3 of them has about 20% of the standard price as a value. That means, practically spoken, if you have a very low environmental cost result, a very low one, you get a very high discount, and the maximum discount you can get on a project is 20% of that standard price. If you have, let's say, from environmental point of view, a not so effective project, then your results are high, and it means you don't get the discount. Now, 20% discount, fictitious discount it is. All those 3 categories give fictitious discounts. They are deducted from the tender price. That gives you a price where the comparison is made between the various projects which are proposed. And in such a way, they can be compared not only on cost level, but also on performance level. And as you saw, the use of geosynthetics result in a lowering of the environmental cost indicator, and therefore make it attractive for contractors to use it. And that means in this way, a contractor or an engineer gets a bonus for using a construction method or a design which result in less environmental or emissions of CO2 or energy. And in such a way, there's a benefit for these kind of designs. So it's paying off. It is not only a comparison and, well, up to the cost. No, it really, if you design with this in mind, you can make a difference of 20% in the tender price, which is quite a lot.
And do the speakers have some bonus system too in their countries to pay for low emission designs?
can give you an idea. But I think that I have it. I love that. So that's wonderful. I don't think that that would work in the US, but I may be wrong. But let me tell you something that I believe that may work as well. The fact that if we calculate it, even if it is to report it, I believe that we can get to good places. For example, and I'm going to get to the roadway applications. When we design a stabilized unbound aggregate, we put a geogrid on a base material, an aggregate. We typically design for two things. Either for a given design life, put geosynthetic and decrease the thickness of the base. That's one option. Second, for a given thickness, put the geosynthetic and extend the design life. Those are the typical solutions. And both of them are more sustainable than the alternative. But I would love to push for two additional ones that I believe that are even more sustainable. So, and those are typically what decides what option to go for is cost. I bet that we can have additional alternatives. For a given thickness, put a geosynthetic and decrease how stringent you are in the specifications of the aggregate. I'm positive that that's going to give lower carbon, embodied carbon. Or even the one that I really think that it is best, and this came out of this discussion of case histories, for a given base, keep the base, keep the quality, put the geosynthetic, and decrease the thickness of the asphaltic layer. So all these are from the performance point of view, they are equivalent. From the cost point of view, I bet that all of them are more cost effective than the conventional solution. But keeping in mind the embodied carbon of alternatives that are equivalent, I think that we can go a long way. So my point, Mr. President, we need to work with designers, because the designers are the ones that can come up with this ingenuity to identify the alternatives that can get us to think out of the box, and potentially with the argument of sustainability convince regulators, which ultimately are going to have the...
We should probably have professional development courses.
Sure. But yeah, but I think that even if we do not have those fictitious costs, which I think that are great, I think that forcing the carbon audit of alternatives will get us a long way. Yeah.
Wim, how long has this system been in use?
I think already 3 or 4 years now on this special requirement on the environmental cost indicators. The system itself is a system which has been fixed by law, how the public tenders are being evaluated. So that system of price quality.
Is it a regional law or is it a national law?
National.
National.
All
So
public.
it went through your legislature.
Yes. So the government public organization, Rijkswaterstaat, must evaluate in this way every middle-size or large tender.
And that's by monetary value of the project? What defines middle?
Pardon?
What defines middle and large? The monetary value?
So every category has about 20% of the tender price, and that is evaluated in a certain way, a certain system, and then that's 1/3 of it, so 20%.
But you said every middle size or large project requires this.
Yes, there's
what defines middle and
in the
large?
process during the tender design, the highest level of requirement, in fact, or maximum acceptable environmental cost indicator level, and the lowest are fixed during design, during the requirements for the project. Like you have to make a road between A and B.
Kent
That is that part.
would like to make a remark?
Yes.
Or
Short remark on that. I don't think the question
And
is, do countries have that or not? I think we have to have it. I think we
Yeah.
have
Here,
to
here.
follow. I think we have to follow what the Dutch did. I mean, you are great geotechnical people. The world learned from you. You learned from the Broadsichtsen a bit from Germany, but not very much. You didn't steal it. Well, to You play worked with football. it. But I think this is fantastic. This is what I said at the beginning of my presentation, that we need that kind of forcement. And I think we have to do it. And it has to go into Europe, and I'm going to take that up into Working Group 7
That's awesome.
and see if we have something. It's a fantastic idea. It's the exact right way to go.
Here, here.
So, do I have to put it on? No. Yeah, Norbert Wagner, President of the German Producers Association. I saw today a lot of solutions, and we have a lot of solutions. The general and the main question for me in all discussion with political stakeholders is, how do we get the criteria of sustainability in a tender? Yeah? For house building and so, we have a lot of certificates, but not for the infrastructure. The Germans try to do everything very perfect, so they gave an order to KPMG to make an evaluation. And this is similar to what Wim said. It's the so-called Schattenpreis project, but it's much more complicated in Germany, as you can expect. Because in Germany, the approach is that the owner has to calculate the carbon footprint for his project. For a road of 1 kilometer, let's say, with everything what he needs to build this road. And then he puts this value in a tender. And then the contractor has a chance to offer what is in the description, but he also has a chance to offer something which has a lower carbon footprint. And then is calculated the carbon volume with a price. The price is for carbon is existing, and this price then is added or deducted to the offer. This means that at the first step, the owner has to do a lot of work. He has to change his approach, and these are authorities who don't want to change anything. And in addition, the contractor also has to do this work. And we asked the German ministry, all these costs which come in addition, which have nothing to do with the project cost, will it reduce the budget for everything what is for the yearly budget for construction? And they said yes. So there's a lot of discussion about this approach. I personally think it's a very good approach, but the way how it will be executed is, for me, not very favorable. I think the Dutch way is much better, but we are Germans, so we cannot. So thank you very much.
Maybe the Germans have an opportunity to copy something from the Dutch in this case. One from the audience here.
You're going to edit this recording, is that right?
Would you like to comment briefly? Or shall I give the floor to Arjan de Bond?
Go ahead.
Yes, hello, my name is Arjan de Bond. My name is again Arjan de Bond. I know for the asphalt business, so not for the geosynthetics business, but for the asphalt business, the Nordic countries, Scandinavia, they are also working with these technologies to make specifications, etc. But they are less sophisticated than the Dutch ones. And I know in Germany, the Bundesland Bavaria, they work together with the University of Munich to also make such a system, but also a bit less advanced than the Dutch. So we're still the number one.
I'll come back. I'm first going to Rijk, who is doing the chat in the online
chat
session.
Thank you. I have a question from the chat, from David Kessman. You are talking about a lot about geosynthetics to make projects more sustainable. What about the use of geosynthetics to help with the issues of climate change already facing? For example, the active layer of permafrost regions is getting deeper. As our climate changes, can geosynthetics be used in these applications too?
There's a similar application for glacier saving, where people have covered glaciers in the Alps with a light reflective geosynthetic. My personal opinion is we're not going to be able to terraform the Earth according to our desires. You know, the Earth is going to do what the Earth is going to do based on the inputs we put into it. I don't think we're going to be able to keep things from happening, other than our inputs to it, CO2 emissions, and then the rigor of our installations will have to sustain what nature throws at us.
I mean, there are possibilities how, again, the question on climate change and stop things, I agree that we're not going to be able. Mother Nature is too strong for us, but we can help things. And there was, I saw in the EAGM, there was a nice case history on where they, in cities, instead of having concrete walls, having plants growing on geosynthetics and watering them with geosynthetics and holding them and making a microclimate in that area. I mean, there are ways to improve territorial areas.
Yes. Well,
glaciers, yes, but permafrost, no. I don't think that's going to
But
happen.
it's harvesting, right?
Yeah.
It's harvesting the CO2. So I think there's the geosynthetic response. There is a geosynthetic response in very specific applications. What we're not going to stop is the melting and the release of gases from the permafrost, right? Or what was from permafrost. So as that thaws, the opportunities are harvesting and vegetation and new forests and
Green roofs.
things like that. Geosynthetic would certainly play a role in.
And help draining the extra water that comes from the frost heave.
Right.
Collecting the water as well, you know, runoff water, which
Right.
otherwise runs away, collected in big basins underwater to make it available and not let it run down into the ocean where it gets salty. I mean, we have to, that's a new future, young generation. That's your job.
One more question for Rijk.
The question is coming from Ulla Inkin. In the first presentation, Mr. Zornberg explained how coarse layers of the road can be thinned using geosynthetics. What might be the situation if there is often freezing temperatures and the ground is frozen for several months a year, like in Scandinavia? We need to consider frost heave always when we are designing roads and railways.
Thank you for the question, because it gives me the opportunity to get to a case history that I couldn't get because I was running late. But geosynthetics have been used very much in Texas for expansive clays, which is volumetric changes and how they add completely different. We do not know how to design for that because roads are designed for traffic loads. These are what is called environmental loads. So is volumetric changes and geosynthetics have been used very well to mitigate the problems of expansive clays and frost heave. So in the US and in Canada, there are different strategies. So I could say that geosynthetics can be used in more than one way. One way is to add stiffening to the base, because essentially a big problem that you have with frost heave and with expansive clays is what is called longitudinal cracks, environmental longitudinal cracks. And the geosynthetics add ductility to the base to mitigate those longitudinal cracks. That's one way. There is a hydraulic way that all these changes, even for frost heave, one of the important distresses in frost heave is that during the spring thaw, you have the edges being essentially unfrozen first, and then the center lines. But it's the same phenomenon. So it's the cross section of the roadway.
Wing flaps.
Yeah, flapping. But it's exactly the same thing. So the answer is a definite yes. Geosynthetics can help in frost heave. There are very good examples. I think that there should be many more examples, but I think that definitely, and in more than one way.
I also hope that they can help the geosynthetics with breaking the capillary flow of the water during the frost season.
Correct. So capillary barriers are a big thing, I think, that in Scandinavia. And a capillary barrier, yeah, and this is counterintuitive,
Yeah.
A drainage layer, a geocomposite drainage layer is a capillary barrier, is a barrier to the capillary
Exactly.
flow.
We have time for one last question, and that will be for this gentleman.
Thank you. Hello, I'm Frank van Hattem. I'm working for Kiwa, and I'm a certification engineer for geomembranes in the Netherlands. And there comes my question from for the geomembrane producers. In the guidelines, but also in all other requirement documents, geomembranes only may be made from virgin oil material. At the other hand, we saw requirements for circularity in Europe for 2050 and earlier already, which implements recycling into the plastic. It's a real problem, I think, because durability, 100 years, and security for, let's say landfill applications, you want to be sure nothing goes wrong. What are the geomembrane makers doing in this respect, and what is going on in the United States in this respect? Can you comment on that?
There's starting to become some differentiation in the grades of geomembrane. Right now, from a regulatory perspective, all geomembranes treated exactly the same. What you put under a hazardous waste site is treated the same way as a 1 millimeter pond that's going to be in service for 2 years and then destroyed. And there needs to be a differentiation there. Geomembranes and geogrids, for example, are probably not the best place to initially use recycled material. But the geocomposite materials, some of the geotextile materials, they're in a position now, or are using now. There's a company called K-Tech in South Africa that's using almost 100% recycled polyester to make their geotextile. So we need to pick it on a case-by-case basis. And there's also this chicken and egg thing with the quality of the recycled stream versus what you're able to use it in. If there's more demand, then there's more economic reason to make a better quality recycle, and that cycle needs to be jump-started somehow.
I'll add something on that, and that's basically, you might remember the beginning of my presentation, the Working Group 7, who's working on that, because we are stuck by the EU law now that we have to allow recycled materials. We're not talking, there's a big differentiation between rework material, which is virgin material, which you just rework. That's not what we're talking about. It's really recycled material. First of all, we heard today that it's more expensive at this rate, but that doesn't matter. That's another story. But if you are interested, you have to go into Working Group 5. It's in the SEN committee, because they just started the work on exactly that topic. They're going to have to generate test procedures, how to evaluate and answer exactly that question what you have. And that's not going to be an easy task for them. It's going to be very difficult, because I absolutely correct. Look in the landfill base seal and have recycled material, because the EU Commission said we have to have that, knowing it's probably not going to last for 100 years. You don't want to excavate that landfill. But we're not allowed to disobey them to be used. So it's going to be a really tricky situation. I can only emphasize experts, like you are one, go into Working Group 5. That's where it's dealt with, and we need a lot of experts there.
One last word for Sam Allen.
Well, a couple of things are very important. One is the IGS will host a very specific workshop in 2025 with regard to recycling. So we'll have because there's a lot going on here. One of the things going on is new technologies regarding recycling. So it's not just taking a product and shipping it and re-extruding it and filtering it and re-extruding it. Now it's really tearing it down and building it back up to raw materials, so much so that it's hard to differentiate between the two. The good thing about Europe and in SIN is you already have 100-year testing protocols that you've already established, right? So from a regulatory standpoint, we don't have that in the US. You have it, so if you jump through these hoops within your specifications, no matter what material it is, if you pass that test, you're able to use it. So you are really ripe for the use of materials. And the last thing I'll say is that in the plastic pipe industry, we did enormous amounts of work in drainage, not pressure pipe, drainage pipe, where we took really very suspect resin and added a very different grades, different amounts by weight of virgin polymer, and came up with beautiful products, absolutely stunningly beautiful. So I think there's work to do here. Florida has a 100-year design life on their drainage culverts.
Not on landfill-based seals and those applications.
No.
What about forcing?
Workshop.
Testing
That's a good one.
samples that are homogeneous for the whole product, but with recycling.
Yeah, right.
There are applications where it's safe. What about forcing recycled plastics in erosion control products? You could.
Brings us to the end of this.
It's a very good topic.